So ladies and gentlemen, here is another scenario for us to actually do right now. And that is the thermometer. Okay, of an oven. Now ladies and gentlemen, an oven is used to cook things. I normally use a microwave. I'm not very familiar with how this oven thing works, but I'm sure it's quite simple. Now, our scenario is this. Our problem is this. If the thermometer is in range, but either or both the fan and the light aren't working, the management system of the oven will output a signal saying alert, alert, alert. Okay, so let's have a look at the key words from our problem. So we've got thermometer is in range. We've got either or both, fan and light. Okay, so let's assign these letters. Oh, I'm missing something. Mr. Levin. We need to output, this is our result, output a signal. So, S will equal signal. That's easy. Now we've already been given the letters for fan, which is A, so let's just put it here. Light, which is B, and thermometer, which is C. And I'll go right out about word oh my, and just go with TH. So, the thermometer has to be in range. And this but will be an and. So the thermometer has to be in range. And the fan or the light aren't working, or maybe both aren't working, so it's either or, then we need to output a signal. So if we had to write, I would like you to give a go at writing that out as an expression. Just like that. That's the solution. So, you've got the signal. And the signal will turn on, so that's the result, if, so you can put an if here instead, C equals 1, which means the thermometer is in range, so that's a 1. You could have actually numbered these up beforehand, it would have made it easier. And A equals 0, the fan's not working, or B equals 0. Now there's a simpler way of writing out, that would have got you marks. But if it says the simplest way to write this out, this bit could be made more efficient. There's a logic gate which will basically say, I will give you the output of it being, let me rephrase that. I'll give you the output to turn the signal on, and to turn the signal on for an alarm, it will be 1. Whilst it's not stated here, it's obvious. For the signal to be off, it will be 0. So what logic gate will literally output 1 for every input apart from when A and B are both 1, where it equals 0. Which logic gate symbol will that be about? What you should have said is the NAND gate, which is this. Really badly drawn again. Now, think about it logically for a second. Let me just show you this using a NAND gate. So that's the same. A NAND B. And what that basically means is, if you think about our scenario, we want our sensor to turn on, so we want it to be 1, when either the fan's not working, the internal light's not working, or they're both not working. And if you remember, the truth table for NAND, let's just do it out quickly, A B. That's not working, it'll still turn our signal on. That's not working, that is working, it'll still turn our signal on, B alarm. If A is working, but B is not working, it'll still turn our signal on. But if they're both working, it won't turn our signal on. So that's the same as doing this. But it's a lot simpler to write this. And it's a lot easier to draw a circuitry diagram using this. Now, I would like you to do the circuitry diagram to show the simpler expression. This one. Pause the video, give it a go. Okay, let's have a look at the solution. There we go. So, we know that C, thermometer is in range, and there needs to be a result of 1 between that and that. So if they're both working, the result will be 0. So 1 and 0 will equal 0. Let's imagine that this wasn't working, but this B was working, and this was 0, so the thermometer is too high. That will also be 0. If that's in range, and that's a 1 because of this, then the signal will be on. There you go. It's a very simple little problem. My advice, practice it.